Hello, Chem 1110 students. We are to the fourth and last set of PowerPoint slides for Chapter 1. And in this presentation, we're going to talk about dimensional analysis. And I want you to know that dimensional analysis is one of the best tools you can learn how to use. It's a procedure that uses conversion factors in problem solving. It's sometimes called the factor label method, if you've heard of that. But what you do is you use your units and conversion factors in order to make sure you get the answer with the units you want. And so you can do problems you don't even know how to do just by using your units. So we have an example here, and that's to convert 12 inches to centimeters. And so what we're going to look at first is the fact that we need to put some sort of conversion factor in here that will go from inches to centimeters. And the conversion factors we have are listed here in the bottom half of the slide. 1 inch is 2.54 centimeters, or 2.54 centimeters is an inch. And so we put that conversion factor in there in such a way that we cancel our units properly. And so the one I want then is 2.54 centimeters over an inch, because that will allow our inch units to cancel. And so when I write it up in there, you can see inches cancel and I'm left with centimeters. So even if I didn't know how to do that problem initially, just by using my units, I can do the math properly. And then I just multiply 12.00 times 2.541 and I got 30.48 centimeters. That result should have 4 significant figures, because the number 12.00 has 4 significant figures, and that conversion factor is actually a definition, and any definition or any counting number is considered to have an infinite number of significant figures. So we conserve the significant figures in multiplication, and so if I have 4 is my least number, at the beginning of my problem, my answer has to have 4. Okay, so we're going to look at a slightly different way to write dimensional analysis, and I have done this with a pen on a computer, so it's not very neat and it kind of looks like kindergarten work, but I think you can get the hang of it. And this is a case where you have a car is advertised as having gas mileage of 15 kilometers per liter, and you know, being Americans, we only know miles per gallon, so we want to convert it to miles per gallon. And I like to actually write out what we know and what we want to know, just to help guide what I'm doing. And then I draw this little grid that is called a railroad track, which makes no sense because there's one track. But anyway, that horizontal line is going to be the divides by line in your fractions, and that vertical line separates the different portions, the different conversion factors that I'm going to use. So what I know is I have 15 kilometers per liter and I want miles per gallon. So I write what I know at the beginning and I write what I need to know at the end, or what I want to know, so I can keep track of those units. So obviously, I've got to get from kilometers to miles and from liters to gallons. So I'm going to start out here with a conversion factor to meters. There are 1,000 meters in a kilometer, and I cancel out my kilometers. So now I have 15,000 meters per liter, which doesn't mean much to me until I put in the conversion for the number of meters in, or how many yards make up a meter. And so it's 1.094 yards in a meter. I put the conversion with the yards over the meters, so the meters cancel out. Now I have yards, and then I know that 1 mile has 1760 yards in it. And so when I cancel the yards, I now have meters on the top, and that's what I needed my answer. So I'm good on the top part of my final units, and now I have to work on volume. And so I'm going back to the liters that I'm starting with, and I put in a conversion to quarts, because we know, being Americans, there are 4 quarts to a gallon. So I cancel my liters, I'm left with quarts on the bottom, and then I say there's 4 quarts to a gallon. So my quarts cancel, and I'm left with gallons. So now I have the miles I want and where I want them, and I have gallons where I want them. And so now I just do the math. And I do the math by multiplying everything across the top, and then I multiply everything across the bottom, and I just divide the two. It's easiest to do it that way versus doing each fraction. So I end up with 35 miles to a gallon, so it is pretty darn good gas mileage. My answer only has 2 significant figures because that initial number they gave us of 15 kilometers per liter only had 2 significant figures. And of course, you see that everything else is a definition, so those are indefinite numbers of significant figures. So conserving my significant figures, I started out with 2, I have to end up with 2. And I did the rounding when I got to the very end, because we know we don't want to round partway through a problem, because we can end up with cumulative rounding errors. So that is dimensional analysis. Here's another example. This was out of the book. The FDA recommends that you shouldn't have more than 2,400 milligrams per day of sodium. And so, how much is that, say, in terms of pounds? And so we say we have 24 milligrams. We know there's 1,000 milligrams in a gram. And then I know there's 453.6 grams in a pound. And so you can see the appropriate units cancel, and we're left with pounds. Looking at this, we are I left that answer with 4 significant figures, which says I'm assuming that 2,400 milligrams per day was 4 significant figures, and it's actually ambiguous because there's no decimal point. It should have been 2400 point to know it's 4 significant figures, or it should have been 2.400 times 10 to the third. But anyway, that is how you use dimensional analysis. And we are done with chapter 1.